Right, good afternoon or good morning. My name's Aaron, I'm from Nullifire. So we're a manufacturer of passive fire protection materials. And today, I'm going to try and talk to you a little bit about kind of some of the issues that we face as a manufacturer when trying to guide the likes of yourselves on a day-to-day basis. Unfortunately, that picture that Alan put up wasn't the worst bit of fire stopping that I've seen this week, even so. So hopefully today you'll pick up a few pointers and tips that will kind of help your installers and help with your sort of fire strategies you go through. So one of the things that I get asked all the time when I say that I'm in fire protection is, so you sell fire extinguishers or smoke alarms or sprinkler systems, those kind of things. And there's a big difference. So first off, those kinds of things are what's known as active fire protection. So active fire protection generally have a signal or an actuator or require a manual triggering. So again, as we mentioned, carbon dioxide, carbon monoxide alarms, sprinkler systems, or gas suppression, that kind of thing, are known as what's known as active fire protection systems. We at Nullifire deal in the passive fire protection, and by its very nature, they form generally part of the building construction. You don't know that they're there until there's an actual fire present, and it's out of control essentially. So the first one is protection of structural elements. So systems like boarded systems, cementitious, intumescent coatings, those kinds of things are what's known as your structural fire protection. We then have the containment of fire or penetration seals, and they're designed to try and help with the compartmentation of a fire within a building. So again, it's trying to stop fire and smoke, toxic gases, that kind of thing, from passing from one area to the next. Now, one of the terminologies that you'll hear quite a lot with fire protection is compartmentation. I'm not trying to teach everyone to suck eggs. I'm hoping a lot of you will have heard of the word compartmentation. And essentially, it's designing a box or an area within the larger part of the building, essentially, to try and stop that spread of fire. If there was in one particular room, it's trying to stop that spread from getting to other areas of the building. Now, that compartmentation, again, will be part of your fire strategy, and that fire strategy will then also determine the time frame that we're trying to stop that fire from getting from one area to another. Now, again, that's based on a number of factors, from the building usage, the building height, the distance of travel to the fire exits, also the number of occupants and the ability of the occupants as well within that building. So, for example, schools, hospitals, university, halls of residences, those kinds of things will have a very different fire rating to a single-story shop, for example. Okay. Now, obviously, the objective of what we're trying to do with the fire compartments is obviously to make sure that everyone can escape out of the building safely. Obviously, make sure that the fire brigade can get in and do their job correctly as well. And also protect the building itself in terms of, from an insurance perspective, but also from any materials, whether it's data or physical within that building. But obviously the priority number one is to make sure that it's saving lives and making sure that people can get out of the building correctly, or if there's a stay-put policy, that they're protected within their safe zones within the building as well. Now, I receive many, many phone calls on a daily basis, and they range from technical questions to just general, can we have a fire stopping detail for X, Y, Z? Now, this conversation and this question is something that, again, as I've mentioned, get asked every day, and it's, can I have a fire stopping detail for a plastic pipe, please, and it goes through a blockwork wall? Now, again, how many of you have probably asked that question? They may have possibly been very, very good and thrown in, oh, and we need it for 60 minutes, okay? And what I'm hoping to do for the rest of this presentation is try and show you some of the terminology, some of the questions, and some of the issues that we face when we're trying to help specify a solution or a tested application for something that you may have on your site. So the first question is the substrate. Okay, so there's a massive range of substrates that are available, from obviously old-fashioned style from blockwork and plasterboard to the more modern methods from white walls, CLT systems, quite a wide range inside of things. Now, again, this is something that we need to ask is, what is the wall thickness of the wall, okay? Is it a 75 mil, 100 mil, 130 mil wall? How many layers of plasterboard? Is it a single skin, 12.5 mil, 15 mil? Is it a fire-rated board? And again, the amount of times that we sort of ask this question and we have a look at pictures and things like that, and we can't always identify it just from a picture. So this is where we need whoever's in charge of the fire strategy to kind of help us as much as possible. And we also then rely on the installing contractors as well to identify the areas that are probably at most at risk. The other things as well is how the openings are formed as well. So has it got a cavity in the wall? Has it been created as a letterbox? Has it been framed? Has it been lined? And all of these different aspects in that substrate will make a big difference to how the fire stopping has been installed, how it's been tested, and how it should be sort of remediated if it's an existing building as well. Just to throw into that as well, we also then have to look at spacing as well. So there's a bit of an issue at the moment where, in terms of, we may have tested down to specific sizings between builders' works holes. So, for example, we will have tested 200 mil spacings between each builders' work holes. But the plasterboard manufacturer, for example, may have only tested to 300. And if you reduce that down, you then start to lose warranties, and it becomes this sort of grey area as well. So again, it's something that we're trying to work with, with the different boards and different guidelines in terms of, the ASFP and those kinds of groups, to try and get a bit more of clarity when it comes to these types of things. So once we've identified what the substrate is, and we've worked out the wall thickness, whether it's a letterbox, it's a cord hole, that kind of thing, if it's a metal deck, etc., we then need to start looking at the penetrations that are going through. So one thing that we offer is obviously multiple solutions for mixed penetrations, single penetrations, and also linear gap seals as well. And that could be from header wall details, slab edge details, to your cavity barrier systems as well. And again, it's identifying multiple different situations here in terms of what the fire rating is, what the service type is, and again, the spacing between each of those services is very, very important in terms of how we test this. Okay. So, as I mentioned, there are a multitude of different services that can be identified. So when you ask for a plastic pipe, we have multitude of different melting points, different pipe thicknesses, obviously different material types, that kind of thing. So what we need to identify this, because it makes, again, a really big difference in terms of what the fire rating that we can offer from a tested solution as a manufacturer. So one of the things that, again, has reared its head is the CPVC systems as well. So sprinkler systems, as we're touching on combustible pipes at the moment. Now, sprinkler pipes, you'll probably notice them as the bright orange pipes that you'll see across site. Now, one of the other things that you have to take into account is the chemical compatibility of these CPVC products. And again, it's become a bit of an issue within the fire stopping arena, as they react to a multitude of different systems out there, plasticizer systems. So mastics, even cables touching the sprinkler pipes, if rubber couplings have been used on the sprinkler systems, again, can cause a number of issues. So again, the reason I bring this up is we've designed a number of special mastics that are basically accredited to be used against certain manufacturers of sprinkler systems as well. Again, it's a pretty common issue that we face on a day-to-day basis. So again, other things that we have to touch on is we say, again, lag non-combustible. What we need to know from yourselves is the slightly more specifics. Is it a phenolic? Is it a nitrile rubber? Is it a rock fiber? What the thickness of it is? How far from the front face of the penetration seal that goes? And what I'm trying to get across here is the days have gone of the old, stick a bit of bat in there, stick a bit of pink foam in there, heaven forbid. Hopefully nobody's using pink foam still for sealing around any penetrations, but it's a conversation that we have on a day-to-day basis is, oh, well, can't you just put something in there to give me 60 minutes? And the answer is simply no, we can't. We cannot just stick something in the hole to fire stop it for a potential 60 minutes. This is the type of information we need to know so that we can cross-reference that with our test evidence and test data. So again, that's leading on to the fire rating that's required. And again, as I mentioned at the beginning of the slide, we get asked, I need 60 minutes, I need 90 minutes, I need 120 minutes. And the first question we ask is that integrity only, or is that integrity insulation? And does it also require load-bearing capacity? And the amount of blank faces or sort of delayed responses that we get at the end of the phone, what do you mean? Oh, we don't worry about the U value on the insulation. And the insulation value is not about how hot or cold it keeps someone in the winter or in the summer, okay? So I'll go through these very, very briefly. So a load-bearing capacity is essentially saying how long will that wall or floor stay in its position during a fire and take the load of the wall or the floor that it's supporting. Integrity is probably the one that you're most commonly familiar with, and that is essentially saying how long will it take for the fire to physically break through that seal, through that wall or through that floor seal. Now insulation is the one that's generally more commonly forgotten about. I am happy to say that it's becoming more prevalent and more thought about when we're looking at sort of fire designs, and people are becoming much more au fait with what the insulation value is. And it's basically preventing the heat spread from the fire side to the non-fire side, okay? So again, in terms of safety of egress and stopping also the sort of leapfrog effect if it's getting too hot on the non-fire side, okay? And it makes a big difference as well about the amount of material that's used as well, depending on as the insulation value goes up, and the insulation value is one of the harder values to achieve in a fire test. Integrity, we can generally get without too many issues. It's the insulation value. It's trying to keep that heat transfer from the fire side to the non-fire side, which is the most difficult part of fire testing. So to, sort of emphasize this side of what we do with the fire testing is test evidence, test evidence, test evidence. I cannot stress enough that when we are giving the solutions to clients and to customers that are having the materials installed into their projects, it's the test evidence is the key thing to what we can supply to you. Okay, now, if you've never seen a fire test before, this is one that's been conducted down at BM Trada in High Wycombe for Warrington, through Warrington Fire. And essentially a fire test is we build a wall, we bolt it into a great big metal frame, bolt it onto the front of a furnace, and we set fire to it. And it's got thermocouples and different measurements all over it. We do cotton wool tests to check where the breaches are for integrity, and we check thermal couples for the insulation values. And when you pull it off, you can see just this sort of extreme temperatures that these fire tests are getting up to put the products through their paces. Once we've got that test done, we then get issued a test report, which is the raw data and generally what fire engineers want to see when they're sort of looking at different solutions. Now, what we try to do is then, that test data is then turned into an ETA report or a certification document, and that makes it a bit more user-friendly, a bit more easier to read than a standard raw data test report. And the reason I've kind of brought this up is the issues that we're facing as manufacturers at the moment, and it's affecting the entire industry. The length of time that this process is taking is, if you said today that we want to take a very specific application that you have on site to test, to get from that test to that ETA certification point at the moment is taking anywhere from about 18 months to 2 years that process, and that's per test. That's per test. And it's slowing lots and lots of things down in terms of being able to offer tested solutions into the market and push the industry forwards from that side of things. Things like deflection is another big talking point. There is no standard that covers deflection head movements and things like that at the moment, with the fire stopping element in it as well. And I can probably see there's a few installers in here probably, calling me names under their breath at the moment for even bringing that up. But it's a constant headache that we're trying to battle within the industry at the moment, is trying to get the standards up to the correct, real life world examples and real life project examples of what we face. So if there's any QSs in here, I'll apologise about this one. But the question of is how much, is that the right question? I think you'll probably know what my feelings are on that one. But the industry is changing. And again, probably the most asked question I got asked a few years ago, pre-Grenfell, was what's the acoustic ratings on it? Never, what's the fire rating? Have you got testing for it? Does it work? Etc. Okay. And what we're trying to get away from is that question of being asked, how much is this going to cost? The question should be, will it work? And the answer is, without being able to look at all of the information that we've just touched on, and again, I appreciate I'm trying to do this in 20 minutes. I could talk to you for about 3 hours on certain pipe types and stuff like that. I'm a very interesting guy like that. But the question is, the answer really simply is maybe, unless we have all of the information that we've just looked at in terms of the substrate type, thickness, wall diameters, pipe diameters, pipe types, etc. There's very little we can kind of give you in terms of, we can give you some standard details that you would go away, but we're more than happy to share with you the test evidence that we have to be able to offer you a system and a solution that we can hopefully get you a fully tested install. Now, again, I know it's already been touched on by some of the sort of previous presenters already, but in terms of your responsibility, now we joke at the moment, I mean, it's a bit of a dark humour, I suppose, but that to become a fire stopping installer at the moment, all you need is a bread knife, a mastic gun, and a van, or an Oyster card if you're in London. And that is the scary thing, is that without the clients or the main contractors checking the competency of the installers that are doing fire stopping work in their job, is technically, you could have your 85-year-old nan come down and do fire stopping, and she wouldn't be doing anything illegal as long as she's got the correct health and safety sign off on site. But and what we're trying to say is that there's a number of different accreditation UCAS bodies out there. Again, LPCB, IFC, and FIRES are sort of three of the probably most well-known names. Is check that the installing contractor that you are using has signed up to a UCAS third-party accreditation scheme and is regularly audited as well by those companies. Okay. Now, again, the regulatory reform order states that it requires you as the building owner or the building manager is checking the competence of your chosen subcontractor. Again, if you're ever unsure, please, come speak to us as the manufacturer. We can give you guidance on installers that we know do work correctly as well. Okay. Again, as you've mentioned before, doing it first time is a lot cheaper than ripping it all out again 6 months down the line, 12 months down the line. Now, I'm hoping this video will work. No, apologies, technical. So what I'm trying to show here is, again, I know Alan touched on the fact of they've done a test with mixing and matching. No, okay. It is quite impressive when you see it, but I promise. So basically, the mixing and matching of products, and it's great that Fire Delay have looked into this. Thank you very much, as if by magic. So sorry, I should explain. The bat on the left-hand side is another manufacturer's product, and the bat on the right-hand side is a Nullifire bat. Now, using a UV torch that you can buy off Amazon for less than a tenner. You can actually shine the UV light onto the Nullifire bats and mastics and identify that the installer has used the correct products. So when you shine a UV torch onto our products, it glows a vivid blue, a bright blue colour. And it's an easy way that clients or building control or site teams can check if the customer, or the installer has used a Nullifire system on site. We've also developed that one step further, and we now have a new taggant pigment that's installed into a lot more of our products. So we have it in bats, mastics, incandescent paint that we use, compound, and our HP mastic, where you can identify that it's a Nullifire product even after a fire has occurred. So even after the products have incandesced and it's been severely damaged during the fire, again, you can check that it's a Nullifire system to, again, one step more to check that it's an approved system. Again, we're kind of speaking to a number of insurance companies on this at the moment to hopefully help with premiums and things. So that's me. I'm just coming up to my 20-minute slot. I was going to open it to questions, but we are holding it. We have an exhibition stand outside, so please feel free to come and have a chat to us. As I said, we do intermittent coatings and cavity barriers, and we'll talk the back legs off you on fire stopping if you so wish. Thank you very much.